In this video, I will introduce the concept of a power set. So let's say I have a set S, and the power set of S, which is represented by the symbol P of S, is the set of all subsets of S. And this description might be a bit abstract, so let's illustrate this with an example. So now let's say S is the set consisting of the numbers 1 and 2. And let's say we want to find the power set of S. Let's say we want to find P of S. Now how do we do that? In order to find P of S, we need to first find all the subsets of S. And so first of all, we know that the empty set is a subset of S, because an empty set is a subset of any other set, as I've proved in the previous video. So we found one subset of S, which is the empty set. Also, we know that the set consisting of the number 1 and the set consisting of the number 2, both of these sets are subsets of S. So you can just apply the definition of a subset to verify that these two sets are indeed subsets of S. And also finally, we know that S itself is also a subset of itself. So this once again comes from the definition of a subset. So we know that the set consisting of the numbers 1, 2 is itself also a subset of S. And so there we have it. These are the subsets of S. And so combining all these results, we can now construct P of S. So recall that P of S is the set of all subsets of S. And so that's why from this we know that P of S, for this case, is equal to the set containing the empty set, and the set which contains the number 1, and the set which contains the number 2, and the set containing the numbers 1 and 2, which is just S itself. And so this expression over here is P of S. And so this is what it means to be a set of all subsets. So let's take a look at another example. Now for this example, let's say S is the empty set. Now for this scenario, what is P of S? In order to find P of S, we need to identify all subsets of the empty set. But the empty set only has one subset, which is just itself. So the only subset of the empty set is just itself. And so that's why P of S only has one element, which is just the empty set. And so this is how you find P of S if S is the empty set. So this is the power set. Before I end this video, I just want to point out one last thing. Apart from P of S, we can actually also express the power set of S as 2 to the power of S. And there are two reasons I can give as to why we express the power set as a power of 2. The first reason is related to functions, but since I haven't defined functions rigorously yet, I'll leave that explanation out. The other explanation is related to the number of elements in the power set. So we can actually prove that for a set S with n elements, we can actually prove that its power set will have 2 to the power of n elements. For example, in our first example, you can see that S had 2 elements, and so P of S had 4 elements, which is just 2 to the power of 2. And now I'll try to give you an explanation as to why this rule is true. Now in order to prove this rule, let's say we have a set S, which has n elements. So S is a set composed of the elements x1, x2, x3, all the way to xn. And let's say we're trying to generate a subset of S. And when we generate this subset, we need to first determine whether each one of these n elements will be contained in the subset or not. And you can see that for each one of these n elements, we have two choices. Either we include it in the subset or we don't. And the same applies for each one of these n elements. Either we include it or we don't. So the same applies to each one of these n elements, and the same goes for xn. We need to decide whether we include this in the subset or not. And you can see that for each one of these n elements, we have two choices. And so that means the total number of possible subsets that you can generate is just 2 times 2 times 2 n times. So you have 2 multiplied by itself n times, which is just 2 to the power of n. And so this is why the power set of a set S with n elements will have 2 to the power of n elements, because there are 2 to the power of n number of possible subsets you can generate from this set S.